everyone. Today I will show you how to create VPC using two Cisco Nexus series switches. Now the question is, what is VPC or Virtual Port Channel? This is a technology that makes these two Nexus switches act like one for your network. Now in terms of layer 2, of course. In terms of layer 3, these are still in individual devices. VPC is what makes them act like one. Now, why do we need VPC or say MLAG, VSS, stacking, virtual stacking? There is a reason for that. Without this technology, your access layer switch will see I have two links to a same network, so spanning tree will disable one. Now you do need high availability for your access layer switch right here. You need for it to have two redundant paths in or out of your network. Without VPC or similar technology, this is not achievable. For that purpose, you will have this, and you are down to one switch for your core. And if that device goes out, your access layer has no way to pass traffic to in and out of your network, or even your inter-VLAN traffic for that matter. Now, with this short overview, I hope you understand why do we need two similar devices for your core or collapse core design, and why we need VPC or similar technology. Now, before you begin configuring your VPC with two Nexus switches, you have to turn on certain feature. For VPC, feature VPC. For inter-VLAN routing, you need feature interface VLAN. For LACP, you need feature LACP. So first I will configure those features on core 1. I will make core 1 to be part of VPC domain 10. There's a reason for this number. I will explain in a minute. Then I will configure management interface with an IP address, and I will create a port channel, let's say port channel 1 using ETH1/1 and 1/2 for our inter-peer link. I will then configure core 2 with similar configuration, and with the help of some show commands, I will show you the VPC status and the state our cores are in. Let's get going. I will start with installing some features. Core 1 VPC related configurations are done. Let's do the same for Core 2. Both the cores are now configured with basic VPC configuration, using management 0 as my keep alive and port channel 1 as my peer link. Let's take a look. It says peer adjacency is formed. That this is using the port channel 1, and keep alive is active. This core 1 is in primary state, and let's say core 2, and core 2 is on the secondary state. I will create a port channel 10, and right here in this configuration I have to mention this is a VPC port channel. This is what will enable the downstream switch to connect to both the peer and not lose one leg. This is one reason that you need to make sure your spanning tree and the spanning tree priority for your VLANs are set identical on these two uplink cores. Let's go ahead and create the VPC port channel for the downstream switch. Alright, as we can see, the VPC port channel 10 is active, and we have on both sides Ether 1.1/5 active in bundle. Now let's go ahead and create a VLAN 2 SVI for our demonstration purpose. For core 1, of course, I will use HSRP. The IP would be .2, core 2 IP would be .3, and the HSRP IP would be .1. Priority for core 1 would be 255 with the highest, and 254 for core 2. So the active HSRP IP will be hosted on core 1. Let's get that going. So VLAN is down. VLAN BD is down. Let's take a look. We have VLAN 2. We do. Let's see over here. VLAN 2 is not there. So this is one place where you would want to check the VPC consistency. So let's see. Show VPC consistency parameters VPC 10. It tells you 1, 2, 3 allowed on active, and 1 is only active on the peer value. So we don't have VLAN 2 to 10 here. Typical mistake. That's why this command is very useful. Show VPC consistency parameters for your VLAN domain. For my case, VLAN 10. VPC 10. So let's go ahead and create the VLANs. Show VPC consistency parameter, VPC domain ID. Okay, no VLANs are suspended. So now check the status on the HSRP. Alright, we're good. there you have it, some basic troubleshooting. For example, right here I can see that my core VLAN 2 on core 2 is active state, and core 1 is standby. This is probably need to wait right here. So it took a few seconds and it became active. Something's up. It is still active on both sides, acting like a split brain scenario. I'm loving this. There's some typo probably. Let's see. Show run interface VLAN 2. Show run interface VLAN 2. I think I made a big typo here on the IP address. Interface VLAN 2 IP address /24. Oh, show run interface VLAN 2. Then we got it fixed now. With the priority core 1 SVI for VLAN 2 is supposed to be active. Let's see if it fixed it. There we have it. Standby is local, and here we have active. Active is local. Wow, what a mess. I made all kinds of configuration error, but what better way to show you active troubleshooting on a live video. Now, during editing, I could have cleared it all up, but I'm going to keep it. Let's go ahead and send some traffic from the Windows PC. I will be pinging the HSRP active IP 192.168.2.1, and then I will go ahead and reload my core 1. Now, before I do that, I wanted to show you the access layer switch and its configuration. Just a basic VLAN 2 SVI. I have a port channel 1 on ETH1.1 and ETH1.2. And I think that's about it. There's nothing major on this one. So let's save it. And now let's go ahead and bring my Windows PC on this side. Go ahead and test with some ping commands. Let's do it to .2 and .3. So we have reachability to both the physical interfaces and the HSRP IP. I'll go ahead and run a continuous ping now. And wanted to show you the VPC role hosted here as primary, and on my core 2 this is secondary. HSRP will be active because this one has preempt and high priority enabled. Go ahead and reload this core 1. Lost 2 packet. Let's take a look at the access layer switch port channel status. Core 1 link using ETH1.1 isn't suspended. It's supposed to be down because of physical layer being down, so it's still suspended. Here I wanted to kind of point out the need for the peer keep alive. So peer keep alive is a link where both the cores kind of send heartbeats and check the status of each other. Once once the VPC domain have been created, there is no such need for that link. If your keep alive link goes down, both the switches continue to act with the role that they have set up. But you need to make sure your keep alive stays on, because if one of the core gets reloaded during the time, even though it will come back with a peer link being up, it will not go into operational state, because with keep alive it needs to detect that the keep alive needs to be up for it to get into operational state. If your peer link is down and your keep alive is on, both the switches know that, hey, my other member is still there, but because of my peer link is down, your secondary switch actually will go into suspension mode. Means any downstream link from that secondary switch, that port channel part would be suspended. Only the active one at this time will be forwarding packets. Then you come into picture as a network guy and you detect that my peer link is down between my two Nexus switches. You will fix it. You will bring the link back up. If there is a configuration inconsistency between these two core, it will never come up. At this point, you have to make sure the inconsistency, fix it, and then the peer link will come up. And after it comes up, it will sync the MAC address table, it will sync your ARP table and any routing protocol related entries, and then it will find everything is good and will bring the peer link up. At this point, your downstream switch also will enable the link to that suspended switch. Here you can see core 1 has come up. Let's check the VPC status. It detects the keep alive is alive, but it is still saying the peer link is down. It will take a few seconds, close to a minute, before this core 1 will get into operational state. During this time, the downstream switch will continue to stay suspended on that link, and I will speed up this video and I will show you the status of the downlink switch ETH1/1. There is a delay restore status timer that will go on. Once that clears out and core 1 gets into operational state, that downstream switch link ETH1/1 want to go into bundle or an LACP and continue to start traffic. At this point, both your cores are operational, both the downstream links are operational. Your downstream switches will continue to work with full bandwidth and connection to both the uplink switches. Peer link is up. It assumed the role primary, but operational mode is secondary. There is a command within the VPC configuration, preempt command, that you can enable for this device to take back the primary role. We have already configured the role priority with 1000 command. I will show you. Here you see the role priority set 1000 because I wanted core 1 to be primary, but there's no preempt command here, because of which it will continue to be operational secondary until and unless the operational primary reloads. So let's check the VPC status again. I see my downstream switch link is up, and here we go. We got the link to core 1 is active in bundle. So take a look at core 2's VPC status. Keep alive is alive, peer link is up, it is secondary, but it is acting primary at this point. All the VLANs are in operational, port channel, all the port channel is operational. If you have multiple port channel going to IDF switches, they will show up here, and you can check the status. All of them are up. Check the port channel status with this summary command. All the legs are up to downstream switches, and they are passing traffic in an active forwarding state. There you have it, friends. Cisco vPC with some few tips and a whole lot of typo and some troubleshooting. I hope you liked this video. Please give it a like if you did like it, and would appreciate if you subscribe. Now, if you want me to demonstrate what happens when management or keep alive goes out while your peer link is up, and on the other hand, what happens if your peer link goes out while your port channel, your keep alive is still on. Please let me know in the comment below, and I would be happy to make that video for you. Thank you, and have a good one.